Okay, today's video is going to be about one simple fact. The fact that if you've got a fraction where the top is the derivative of the bottom, so basically if you differentiate the bottom you get the top, so the numerator is the differential of the denominator, then the integral of that will be natural log the modulus of the bottom part of it plus c. Well, the plus c if it's an indefinite integral, obviously. If it's a definite integral, you can omit the plus c. That's a mouthful, so let's go through some examples. So here we've got 1 over x. Clearly if you differentiate x you get 1, so the rule applies. And we get ln modulus x plus c. Pretty damn simple. Sometimes you're going to get things that can simplify down to 1 over x. So for example 3 over 3x, that's obviously just going to become 1 over x. You get ln x plus c. Sometimes you're going to get things that don't quite differentiate. So differential of x is 1, not 5. So if you take the 5 on the outside, you got 5 integral of 1 over x. And remember I told you this, I've got kind of a big fuss about it. Like, in fact, you can take out numbers from both differential signs and integral signs and put them on the outside where it's convenient to you. Here's an example of us doing that. Take the 5 out, and now the integral is 1 over x, and we know how to do that. So it's just 5 times ln x plus c. Don't need to times the c by 5. A constant just swallows that. Just to show you that that always does work, let's show you x squared over x cubed. Obviously that's just 1 over x, but I've used a different method here. I'm going to use the fact that if I put 1/3 here and I put a 3x squared, 1/3 times 3x is 1/3 times 3x squared is just x squared. So you get 1/3 ln of x cubed. But remember from the laws of logs, and this is something I'm going to use again in just a moment, if you have a number on the outside, that's actually just going to be a power of the thing that's inside the log. So that's basically x cubed times 1/3. So 3 times 1/3 will just cancel to be 1, so you get ln x again, just like I claimed here. So simplification or doing the division or multiplication, the manipulation of the integral, works out in the same way. You end up with the same answer. Here's one that's a little bit more interesting, good old tan x. So sorry about that, it's a bit of a wobble there. What's going on with tan x? Well, tan x is sine over cos x, and that's almost going to work. Differential of cos is minus sine. So if we stick a minus sign on the front, we can say minus minus sine x, well, that would be just sine x, so that's okay. So that gives us ln cos x plus c. Now, if any of you guys have been reading ahead, you'll know that that's not how the answer is given. In the formula booklet, if you look at last year's formula booklet, I don't know if you get it this year at all, but minus ln cos x is not what we do. Put the minus on the inside, and what's 1 over cos? It's nothing but sec, so hopefully you've actually watched the sec videos, sec, cosec, cot. So that's ln sec x plus c, and that's what the integral of tan x is. So I'm just going to set you a little challenge. What's the integral of cot x? Now that's much easier. You don't need to mess around with any minus signs, but I'm going to leave that for you.